here we go again. I am back to remind you how to multiply and factor polynomials today, which you will definitely need in Algebra 2, so it's super important that we go back over that. Hopefully you guys are all staying safe and sane and healthy. I miss you. Every day I miss you. But let's get to the math, and if you have any questions, make sure you email me, or if you just want to say hi, email me then too. Okay, so I'm gonna go ahead and put us right on screen here. Remember, take the notes and it will help you out to answer the assignment. Okay, so we are going to begin with remembering what to do when we multiply polynomials. And okay, so what we're going to start with is multiplying a binomial by a trinomial. And if you recall, we learned a handy-dandy little method of multiplying polynomials by making a box. Okay, so we're going to take our first binomial and we'll write that going up and down, 2x plus 2. And you can go the other way if you want to. But because I need the space, I'm going to do it this way. And then I'm going to take my trinomial, 8x squared, and I'm going to write it across, minus 3x plus 6. And I'm going to use this box method to multiply each term by each term. Beginning with 2x times 8x squared. Now, let's not forget, there's some rules when multiplying. You need to first multiply the base numbers. Then, after you multiply the bases, you need to add exponents here because we are multiplying. Okay, so what that means is when we multiply 2x to the 1 power, technically, times 8x squared, well, 2 times 8 is 16, and x to the 1, and we're going to add the exponents, plus x to the 2 would give us x to the 3rd power. Now we're going to go across this way, and you can go up and down too, it doesn't matter. 2x to the 1 times negative 3x. Well, 2 times negative 3 is negative 6, and there's a hidden 1 on this as well. 1 plus 1 gives us x to the 2nd power. And then last but not least here, 2x to the 1 times positive 6 would give us 12, and there's no exponents to add, but we do need to keep that x, or x to the 1 power. All right, now moving down to the second part. 2 times 8x squared, well, there aren't any x's on this, so 2 times 8 is 16, and x squared stays the same. Now 2 times negative 3x to the 1 would give us negative 6x. Again, no exponents to add there, and you can put the 1 on if it makes you guys more comfortable. And then 2 times 6 would give us 12. Now, that gives us all the individual terms, and now we have to do what we did in the last video, and that is add the like terms together before we write it all out. So, again, you want to start with the largest exponent because we are going to write it in standard form. So 16x to the 3rd power has no like terms. We're going to keep that. You'll notice that like terms generally will make a diagonal. So 16x squared plus negative 6x squared is going to give us positive 10x squared. And then here we've got negative 6x to the 1 plus 12x to the 1 would give us positive 6x to the 1, or positive 6x. And then finally 12 is lonely, but that's okay. We're going to add him to the end. And so we end up with this big old 4-term polynomial, and none of those terms can go together, so that is the answer. Okay, good. Hopefully everyone remembers doing that. It is very similar if you have, no matter how many terms you have. So we have a trinomial by a trinomial. You would do the same exact thing. You can do this without the box by going this guy times this guy, then this one times this one, then this one times this one, then going back, this one times this one times this one, and so on until you're done. The box method just gives you a little bit better way to organize your thoughts. So 5x squared minus 5x, and minus 3 go along the side. And again, you can do it the other way if you want to. 9x squared plus 7x, and then minus 1. And you just want to make sure you separate your terms so that you don't get confused. Ooh, wow. Sorry about my lines here. They're a little bit crooked. Okay, so again, we're going to multiply each set of terms. So 5 times 9 is 45. X squared, we're going to add those and get x to the 4th. Okay, 5x squared times 7x give us 35x. There's a 1 on there, so this is now x to the 3rd power. 5x squared times negative 1 is going to give us negative 5x squared. And now we're going to move down. Negative 5x times 9 is negative 45x. Now this is just a 1, so this is x to the 3rd. Negative 5x times 7x is going to give us 35x to the 2, because again, remember there's a 1 on there. Negative 5x to the 1 times negative 1 is now positive 5x to the 1. And last but not least, our last row, negative 3 times 9x squared is negative 27x squared. Negative 3 times 7x to the 1 is negative 21x to the 1. And then negative 3 times negative 1 is positive 3. Whew, lots of terms. But when you go to rewrite it now, the diagonal terms we're going to add together again. Okay, so 45x to the 4th is going to be our starter. There is nothing that goes with that guy because there's no other 4th power. Okay, again, we're diagonal. Negative 45x to the 3rd can be combined with positive 35x to the 3rd to give us negative 10x to the 3rd. Those are done. And now we have 3 that can go together. Negative 27x squared plus positive 35x squared plus negative 5x squared. So use your calculator if you are unsure. But sometimes it helps to go, all right, negative 5 and positive 35, I'm left with positive 30x squared plus negative 27x squared gives me positive 3x squared in the end. No. Yes. Okay. I just went a little bit crazy there, right? Okay, 27. Yes, I'm right. Okay. Woo, I had to second guess myself there for a minute. Okay, negative 21x to the 1 plus positive 5x to the 1. Okay, so again, use your calculator to double check if you need to, but that should give you negative 16x. And I'm going to put the 1 on. Technically, you do not have to do that. If you're taking a test, that 1 won't be on there. It'll be just the x. And then r plus 3 at the end. Okay. And so this guy is quite the polynomial, but it is our final answer. Okay, so I decided today that I'd start with the harder part, the more tedious part. And we're going to wrap up by remembering how to factor out a greatest common factor from a polynomial. So let's look at example 3. Remember, when we are factoring, it means we're going to put the parentheses back in. So up here, we took all the parentheses out. We wrote it out as the long way in the standard form. Now we're going to take standard form and we're going to put those parentheses back in. So what you want to do is first look at your base numbers and say, all right, what is the largest number I can divide 64 by and also divide 24 by? Okay, and so the biggest number that can go into both of them is going to be 8. So we're going to take an 8 out and we're going to set it out to the side. Oops, not parentheses yet. Hold on. Ooh. 8, set that to the side. And so the next thing I want to look at is my x's, okay? And I want to see if I can take any x's out. Well, technically, what this means right here is I have 8 x's multiplied by themselves. And over here I have 3 multiplied by themselves. So what that means is I can take a total of 3 out of here and a total of 3 out of here, because if I try to take more, there's not enough on this side. So I can take 3 x's out. That's our greatest common factor, is 8x to the third power. Now, what's left then we put in parentheses. So I'm dividing the bases, and I am subtracting the exponents. Okay, so it is just the opposite of what we did above. We're dividing our bases and we're subtracting exponents. Remember, we wrote it up here: multiply bases, add. Now we're dividing, subtract. So 64 divided by 8 is 8. 8 minus 3 leaves us with x to the 5th. 24 divided by 8 is positive 3. And x to the third, and if we subtract 3 x's out, we don't have any x's left. And so that is our final answer in factored form. Okay, last one. Let's try one more here. And this is a trinomial. Again, same process. What is the greatest number that you can divide -6, 15, and -39 by? Okay, so you got to think about that for a second. And the answer to that, hopefully you came up with 3. Okay, so if we divide each of these by 3, we can do that. What's the maximum number of x's that can come out of each term here? Okay, if you have 5 here, 4 here, and 6 here, the maximum number that can come out is 4, because this guy only has 4. So we're going to take 4 out. And then we're going to divide each of these and subtract each of these. Okay, and so 6 divided by 3, -6, excuse me, divided by 3 is -2. 5 minus 4 leaves us x to the 1, technically. You don't have to have that 1 on there. 15 divided by 3 is 5. X to the 4 divided by x to the 4, well, that leaves us none of those left. And then -39 divided by 3 is -13. X to the 6 over x to the 4 leaves us 2 x's left. And that is our factored form of our polynomial. Okay, that was kind of a lot today, and I apologize for that, but you guys are the algebra kids, so I know you can handle it. There are only 4, I think, practice problems for you to do today. Hopefully, we can just keep your skills sharp for next year then. Okay, if you have questions, please email me. I will talk to you all soon. Have a great rest of your day.